Alrighty, now lesson 48, we sort of, I think, set up the expectation of what kind of moves we're going to be making to do a sort of, what was that lesson called? That lesson was called the brute force approach to solving systems of equations. We're going to continue using the brute force approach, except we're going to make it a little easier, I think, to write our steps down, and we're going to hang some terminology on it as well. So first of all, in the name of not having to write quite so much down, you see that system of equations there? That's writing too much down, don't you think? Look at all that. Why are you writing x's all the time and y's all the time? Why do you even write the equals? You don't have to write all this stuff. You don't have to write all this stuff. The key information here is basically what are the numbers. So here's what we tend to do. We say 2, 3, and then we put a line here, 10, 3, -2, -11. Isn't that spiffy? You know what that is. It represents exactly this. 2x, 3y equals 10. 3x minus 2y equals -11. So it's just a shorthand for the equations that we're looking at above. Now this happens to have a name. It's called an augmented matrix. Usually matrices, I'm not going to say usually, but often they tend to be square things. Like you might have what's called a 2x2 matrix where you have 4 numbers in it. Well, this one's got like an extra column to it, right? It's got like this extra thing over there. That's why we call it augmented. And in particular, this line here represents an equals sign. So the coefficients over here are showing up over here, a 2, a 3, a 3, a -2. And then on the other side of this line here, these are the what they equal. They equal a 10 equals a -11 and so on. So it's called an augmented matrix. There, that's your first vocabulary word for today. So what would we do to solve this system? We would, remember we were started doing things like we'd take aim at this upper left and say, oh, I want to make that a 1. And remember how we would make that a 1? Well, looking at the equation, it's a little natural, I think, to say, how do I make the 2x into a 1x? I divide everything by 2. Everything. Divide the whole equation by 2. So here's a notation for that. You ready? We're going to say, take the first row, r sub 1. Instead of calling it an equation, we're not calling it a row. Take the first row, divide it by 2, and store that as the new row 1. See what I mean? Small r means old row 1. Big R means it's going to be the new row 1. And by the way, this is our second piece of vocabulary today. This is called a row operation, because we're going to operate on the first row. Get it? So here we go. Let's do that row operation. The first row is going to become what? Well, you take the 2 and you divide it by 2, and it's a 1. You take the 3 and divide it by 2, and it's a 3/2. You take the 10 and divide it by 2, and it's a 5. So it is, in fact, it's like taking this equation and dividing everything by 2, except we don't have to write the whole equation out. We just take all the numbers that are in the row there, and we divide all the numbers by 2, row operation. This row here, we're not going to change. We're going to leave it the same. Okay, cool. We've just done our first row operation. Now remember what we were doing before. After we had got a 1, we would want to make that into a 0. And that was a slightly different operation, because to make 0 show up, you have to combine 2 equations or 2 rows together. So what are we going to do here? We're going to, since that's like a 3x, what we'd like to do is make that a -3x. So we're going to take the row 1, multiply it by -3. Then we'll add the row 2. This will become our new and improved row 2, hence the capital letter. And that's another row operation. Notice there are only 2 basic types of row operations. You have the type of row operation where you're making a 1, like this one, and you have the kind of row operation where you're making a 0, like this one. You make a 1 by a straight multiplication or division. You make a 0 by adding 2 equations together. Anyway, so let's see now here. That's going to become our new row 2. So we're not changing the row 1. So I'm just going to copy that here as is. But we are changing the row 2. Now after a while you can just look at the numbers and do this. In fact, let's see if we can practice that right now. So if you take -3 times this, that's a -3. You add this, you get a 0. Okay, that worked. Now, let's do that next row over. -3 times this, you take the element in row 1, -3 times this, and then you're going to add this. So that's going to be a -3 times 3 halves is a -9 halves. That's going to be a -9 halves. And then you're going to add the -2 to it, which is like a 4 halves. You're going to get a -13 halves. Cool. And then you got to do the same thing over here. It's -3 times each element in row 1. So -3 times 5 is -15, and then you add this. -15 and a that is a -26. Wow. Okay. And this, we copy the system over and over. It's a little bit easier if you can just use this this matrix notation. So notice we're zooming right along here. We got the 1 there, we got the 0 there. Now we want to make that into a 1, right? So that's another row operation we're going to have to do here. Let's do another row operation here. Let's get rid of some of this green stuff. Green stuff. Green stuff. So I just want to make a 1. That's the easy kind. So I'm going to take row 2 and I'm going to multiply by the reciprocal by -2/13. And that will become my new row 2. So row 1 is staying the same. A 1, a 3 halves, a 5. Row 2 is getting changed. Take each element in row 2 and multiply it by this. 0 times that is still 0. That's nice. This times this, well, it's reciprocals. They just become a 1. So that's a 1. And then you got to take this -26 times a -2/13. So what's that end up being? Well, the 13 cancels into 26 twice. -2 times -2, you actually get a 4. Cool. So we've done our row operations. We've got ourselves the sort of the beginning of the end here. Notice the bottom row gives us one of our answers, y is equal to 4. This is the time when we started to bubble up. But before we start bubbling up, I got another word for you. This is called Row-Echelon form of the matrix, of the augmented matrix. Row-Echelon form. What makes it Row-Echelon form is that you've got 1s on the diagonal and 0s underneath. 1s down the diagonal, 0s underneath. So if you had a bigger system of equation, you'd have more 1s coming down the diagonal and you'd have a lot more 0s underneath. Okay, so that's the key feature. So that's kind of our initial goal. 1s down that diagonal, 0s underneath. And again, we call this initial goal Row-Echelon form. We've used row operations to convert our augmented matrix into Row-Echelon form. Woohoo! Happy city. Like I say, you know you're there because the bottom row now contains your solution, y equals 4. One more word. One more word. Okay, so we now set about doing one more word. The word is called back-substitution. So this process of bubbling up to get the rest of your solutions, it has a name too, back-substitution. So take y equals 4 into row 1, and you get, let's see, row 1 says x plus 3 halves y, but y is 4, is equal to 5. So notice we're going to be able to solve for x here. So this is x plus, that would be, let's see, 2 cancels into the 4 twice. We got a 6 equals 5, and so that means x is equal to -1. And so your solutions are x equals -1, y equals 4. We just solved our system. Isn't that cool? So let me come back up to the top of my list. I hope that went rather well. It is, of course, very similar to what we were doing Last time, it's just that now we're using this new funky notation and some of these new words. Let's see, did I introduce all my keywords? Augmented matrix, yep. Row operations, row echelon form, back substitution. Beauty. We got them all. Okay, let's do one more example, just to sort of fly this lingo around some more. Fly it around, fling it around, whatever we're doing. Make it go around. So let me first shrink this up a little bit. Okay, cool. So I can get it out of the way. We'll do a nice 3x3. So, what's the process? First, the process. Make yourself a nice augmented matrix. Remember, the essential information is just what are the coefficients. So we take our coefficients and we put them in our little augmented matrix thing. Cool, 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 cool. Darcy blows. Augmented matrix. 2, negative 1, 4, 6. 1, 2, negative 2, negative 5, 4, 3, 8, 2. It's worth it, by the way, to check your steps when you're doing this stuff. You hate to get to the very end and go, oh man, there's a mistake somewhere. What'd I do? So anyway, now that we've got our augmented matrix, we start at the top left, and we say, okay, first I need to make that a 1. I need a row operation that makes that into a 1. Well, row 1 divided by 2, that'll do it. That will become our new and improved row 1. So, and what I love about this, it really is a row operation because you're taking all the numbers in the row and that's what you're doing to them. You're dividing them all by 2. So I'll have a 1, that'll be a negative 1/2, that'll be a 2, and that'll be a 3. The other 2 rows I am not changing at the moment, so I'm just copying them along. This is sort of like the state of the memory banks in the computer right now. The only thing we overwrote was the first row. Okay, cool. We've got our 1. Good. Now we want that to be a 0. You get zeros by adding equations together. So it looks like if we take negative 1 times row 1 and add row 2 together, that'll give us a nice row 2, right? Just multiply this by negative 1, this whole row by negative 1, and then you can add row 2. So row 1 is not going to change. I'm overwriting row 2, so I can just copy this one in. But now carefully, negative 1 times this plus this, that's going to give me a 0. Negative 1 times this plus this, that's going to give me a 2.5, which is the same as 5/2. Negative 1 times this plus this, that's going to give me a negative 4. Negative 1 times this plus this is going to give me a negative 8. That's my new row 2. Row 3, I did not change at the moment. Okay, cool. Making progress. I got my 1, I got my 0. Oh, I want that to be a 0. I also want that to be a 0. So let's see now here. How am I going to do this? I'm going to have to take, remember you add equations. So you come looking up to here and you say, gee, if I multiply the first row by negative 4, that'll help. Because that'll give me a negative 4x, so to speak. So negative 4 row 1 plus row 3, that will become my new and improved row 3. So the first row is not going to change. The second row is not going to change. The third row is going to change. So very careful now. Negative 4 times this plus this will be a 0. Negative 4 times this is 2. Plus this is 5. Negative 4 times this is negative 8. Plus this is 0. Well, that's kind of fun. And then negative 4 times this is negative 12. Plus this is a negative 10. Okay, here we are. And I'm just going to keep going down. What's my next target? The next target would be here. Remember, row echelon form is going to be 1s down the diagonal and 0s underneath. So the first column is all figured out. I got the 1 there. I got the 0s underneath. Now I got to move over to this next column and say, okay, I need that 5/2 to become a 1. How to do it? How to do it? Well, you multiply by reciprocal. So row 2, the old row 2, times the reciprocal, which will be 2/5. This will become the new row 2. So the first row is not changing. Just copy those numbers. The next row is changing. Everybody times 2/5. 0 times 2/5 is 0. 5/2 times 2/5 is 1. Negative 4 times 2/5 is negative 8/5. Negative 8 times 2/5 is negative 16/5. And then this row is not changing either. Okay, here's the state of our computer memory banks now. Make that a 0. How are we going to make that a 0? I want to add my two equations together. I want to multiply row 2 by a negative 5, basically, and then add row 3. Whoops, I want to use a small r. Let's make sure I write this down correctly. Negative 5 times row 2, adding row 3. Yeesh. Yeesh. That's a 3. Okay, that's going to become my new and improved row 3. So, again, the first row does not change at this point. The second row does not change at this point. But the third row, okay, negative 5 times row 2 times row 3. Negative 5 times this plus this. Notice that does give me a 0. Okay, negative 5 times this plus this gives me a 0. Negative 5 times this, notice the negative 5s are going to cancel here. A negative 8/5, and then when I multiply by a negative 5 over 1, the 5s are canceling. I'm getting just a positive 8. And then negative 16/5 times a negative 5. The 5s are canceling. I'm getting a 16 plus a negative 10, so that's a 6. Not bad. We are making such progress. Such progress. Let's turn that into a 1. That's where you simply take row 3, divide it by 8, and call that the new and improved row 3. We are almost at row echelon form. Let's see what we got here. We got this row stays the same. This row stays the same. And this row is being multiplied by, well, it's being divided by 8. 0 divided by 8 is 0. 0 divided by 8 is 0. 8 divided by 8 is 1. And 6 divided by 8, might as well reduce. It's 3/4. Row echelon form. Ding, 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 ding. That's a good place to be. Now that we're at row echelon form, it basically means we're already looking at one of our solutions, z is equal to 3/4. It also means we're about to do back substitution to solve for x and y. Back substitution time. So if I bubble up once, row 2 says 0x plus y minus 8/5 times z, but z is 3/4. And that's equal to negative 16/5. Okay, this should simplify somewhat. Notice the 4 cancels into the 8 twice, so that's cool. So what I got then is I got y minus 6/5 is equal to negative 16/5. So if I add 6/5 on both sides, I get a negative 10/5, which is negative 2. Y is negative 2. So z is 3/4 is one of our answers. Y is negative 2 is another answer. And now we take those two up to the top equation. This one says 1x minus 2 times y, which is negative 2, plus 2 times z, which is 3/4, is equal to 3. Okay, so x plus 4. Here the 2's will cancel. That's like a 2 over 1, so the 2 cancels into 4 twice. I got a 3/2 there. So plus 4 plus 3/2, and that equals a 3 on that side. So if I subtract 4 on both sides, and then I subtract 3/2 on both sides, I'll have x equals 3 minus 4 is a negative 1. Negative 1 minus 3/2 is a negative 5/2. And there she blows. Negative 5/2, negative 2, and 3/4. Those are our solutions. And I'm just going to double check. I solved this one before, didn't I? Where the heck is it? Yep, I solved it and I also put it away. Oh well, but this looks good. It's coming out to nice fractions. I was expecting some nice fractions and nice whole numbers. I believe it's right. So how do you like the process, huh? Got to admit, It kind of grows on you, right? By the way, is that a good thing if something grows on you? I'm not sure if that's a good thing or a bad thing. You get to like it. That's what I'm trying to say. You get to like it after a while, especially if you're a computer, because you can just crank this stuff out. And what's nice is we've only done a 2x2 and a 3x3, but you can see how easily, using the word in quotes, how easily you could ramp this up to do a 5x5 or a 6x6 or an 8x8 or a 20x20. Takes you longer, but you know what the steps will be. And it's nothing to do with getting, 20x20, determinants. It's nice. I like this method. It's a good method. All right. So the next time we'll actually come back to the world of world problems, and I can show you where these things really get used.